Hello, my name is Ayush Thorin, and I have created a line plotter that uses Bresenham's line algorithm to draw a line between 2 points. So this is a visual demonstration of the algorithm I have created in JavaScript using the P5 library, which helps with visualization and drawing. So as you can see, it has a few features such as just the basic clicking, you can clear the points, and you can change the mode based on how you would like to draw the points. So you can either have them all connect, you can only make it the last one, or you can use pairs. Alright, so all of the code is open source, and actually, let's turn on dark mode here. Okay. So in the info tab on Open Processing, which is a great website for coding in P5, all my credits here and my change logs. So if you'd like to see my process for development, I think I did a pretty good job of writing all the details in here. And of course, check out all the sources. But the code actually gets started in my sketch. So the project does feature scaling GUI, just for some quality of life. So no matter what size your screen is, the GUI still should fit pretty comfortably, no matter what the resolution and stuff, because it dynamically adjusts, um, including like all the buttons and the text and everything. So the first tab is the grid class, which handles the grid itself and like clicking on it and plotting the lines. So the main algorithm for Bresenham's algorithm, which I translated into JavaScript, starts on line 90 and ends on line 112 or 114. So it is quite complicated, and basically here's what it does. So this is another great feature of the sketch. You can change the size of the squares. So if I change the square size to 160, that'll make them a bit bigger. So I'm gonna draw 2 points right here. And as you can see, it draws a pretty blocky line on the grid because the squares are so big. But how it works is that it basically plots the line on like an imaginary line, like a nice smooth line. But of course, it can't just fill in whichever squares that it touches, because that would result in a thick and even more blocky line that's not truly accurate. So how do we find out which square to fill in then? Well, the algorithm basically aims to find out if it should either keep going straight or if it should go up or down when drawing the square. So it actually uses something called the error, which is the distance from the actual point on the line to the center of the square. So this basically, whichever square has the smallest error to that line itself, that's the one that's going to be chosen because it's the closest to what the actual line should be. So hopefully that makes a bit of sense. And maybe if you look over it for a while, you'll be able to pick apart the different parts of this algorithm. I'm not going to go over all of that in this video, but basically the rest of the project is mostly the visualization and handling all the clicks and stuff. Um, it has a pretty nicely optimized system. So yeah, um, like clicking on the grid, it gets the mouse's position and finds which square it is hovering over, which is a pretty neat little system, which I actually revised from a previous system where it would go through every square and check if the mouse was on top of it, so kind of reversing things there. And that was severely unoptimized and would create a lot of latency when clicking. And then the different modes basically rely on a system I created where the different squares can basically be locked off from creating lines. So, for example, in all mode, the squares never get locked off because they're always forming new points with every new point. In last mode, The last square doesn't get locked off, but the one before that does, so that only the last one can form a new connection. And in pairs mode, both of them will be locked off because they can only form one line, and that is with each other. So yeah, that's a pretty simple system, pretty easy to implement. Did go through a few revisions, but I'm happy with how it turned out in the end. And finally, the buttons also use just point to rectangle collision detection, which I actually got, as you can see, from jeffreythompson.org, a great website for collision detection algorithms. And P5 does come with built-in buttons, but I felt that custom coding my own would make them look prettier and it would just be like a fun little addition. So yeah, and there's FPS monitor to see how laggy it is, and the millisecond display basically tells you how long it took to draw the line. So it measures the time between the click and the rendering of the line being finished. So it stays relatively low. Um, it's not completely accurate all the time, just because the project does freeze if you go into like all mode and just do a lot of points, but that's in very specific and very resource consuming circumstances. Okay, now some of you may be more familiar with the website Replit, which I've also ported the code to, so if you would like to see that version, that's completely fine too. All of the links to the code, the open processing, Replit, and the GitHub links will be in the description of this video. So it's just personal preference really. And as I said, the code is on GitHub, so be sure to check that out. It has the all of the info out here if it's hard to read in the comments in open processing or GitHub or Replit. Um, and yeah, all the links are here, YouTube videos and stuff. And yeah, so I hope you do play around with the visualization a bit. And yeah, so if you can change up the code to whatever you like, you can explore all the variables and change those. Um, and if you have any suggestions, you can maybe make a pull request on GitHub. That'd be great. I've love to hear some feedback on that. Anyways, thanks for watching and see you in the next one.